Hey guys, so we're going to do a video on why there's a curve when there's acceleration on a um, position time graph, right? An XT graph. I feel like we've talked about it and I've explained it, but I feel like there's still a little bit of confusion as to why. And I think this will help to clarify some things. So what I'm going to do is kind of show you quantitatively how much displacement there is when you have acceleration. So we have an equation that you don't need to know at this point. You will this unit, but not this second. And kind of get some numbers and then plot them on a graph and see what that actually looks like. All right, so there's a graph, an equation that we use for displacement. It is my change in x, right? That equals displacement. My initial velocity times time plus 1/2 my acceleration times time squared. All right, we're going to get to this soon. Now, if we assume that we're trying to figure out what a position time graph would look like if an object is standing still and then has an acceleration of 1 meter per second. So if that's the case, if they're standing still, their initial velocity would be 0. Their acceleration would be 1. All right, so I'm approaching things in the similar way that I've done all the problems, right? List out my givens, what do I have, and then I can plug them into this equation. So I'm trying to solve for this, but this is 0. So if that's the case, then 0 times anything is going to be 0, so I eliminate that. Now I just have this to work with. All right, so I'm going to make a little table over here, right, of my displacement and my time. All right, so if I plug numbers in, spit them out, I can get some data points, plot them on a graph, and we can see what shape it shows us. Right? We have acceleration present, so we're going to see if it actually gets a curve or not. So 1/2 times a is 1. We'll say time is 0. 0 times all this stuff. At time 0, it obviously hasn't moved. Right? This is an important point to use when you're graphing. Now we put 1 in here. Right? So I have my change in x equals 1/2 times 1 times 1 second squared. 1 squared is 1 times 1 is 1. Half of that is 0.5. So at 1 second, we've gone 1/2 meter. All right, then now let's plug 2 in there. 2 squared is 4. Half of that is 2. Right? So after 2 seconds, I've gone 2 meters. Or I'm at position 2. All right, then now it's 3. 3 squared is 9. Half of that is 4.5. All right, 4, we'll just do 5 data points here. All right, put 4 in here. Remember, this is time, so time equals 4 seconds. 4 squared is 16. Half of that is 8. All right, then I do 5. At time equals 5. 5 squared is 25. Half of that is 12.5, which is off our scale. All right, so now what I can do is I can take this and I can plot it on a graph and see what the actual shape is. So we have acceleration, 0, 0, so I start right there. All right, then time equals 1 second. Each dash is 1/2 a second, just to spread it out a little bit. So at time equals 1 second, I'm at 0.5, so I'm right there. At time equals 2 seconds now, I'm at 2. At time equals 3, I'm at 4.5. At time equals 4, I'm at 8. Right, time equals 5, I'm actually off, so I'm up there somewhere. All right, so now if I connect these, all right, I have a curve. It's kind of an ugly looking curve, but it's a curve. All right, so I have it increasing the amount of displacement it has as every second goes by. We can see that numerically here, right? Between the first second, it went 1/2 a meter. But between the first second and the second second, it traveled 1.5 meters further, right? I'm just taking the distance between them. Then it went 2.5 meters further. Then it went 3.5, and then it went 4.5. So it's adding more and more every single time. And because of that, because it's covering more distance for every second that passes, and then I increase exponentially upwards, and that requires a curve when there is acceleration. All right, so when you have acceleration present on a position time graph, you're going to have a curve. Now, the curve can look different, and we're going to go over that on another video. They can look different But I wanted to show you with some numbers on a quantitative graph. Again, kind of an ugly looking graph, but gets the point that there's going to be a curve when there's acceleration. And you see it kind of slow and then it increases pretty quick. All right, so hopefully that kind of clarifies a little bit. Curve when acceleration is present on an XT graph.